an expanse so vast it could swallow the entire United States and still have room to spare. A place where temperatures soar to 136 degrees Fahrenheit by day and plummet below freezing at night. Where ancient civilizations rose and fell, where rivers of sand flow like water, and where life itself becomes an act of defiance against impossible odds. This is the Sahara Desert, the greatest hot desert on Earth, spanning over 3.6 million square miles across North Africa, from the Atlantic Ocean to the Red Sea. But here's what most people never realize. The Sahara isn't just sand. It's a living museum of Earth's climate history, a testament to human ingenuity, and a landscape so geologically diverse that it contains everything from volcanic plains to salt lakes, from prehistoric rock art to cutting-edge solar technology. This desert holds secrets that rewrite our understanding of what empty really means. What would you do if you had to survive in a place where rain might not fall for years, where a single wrong turn could mean the difference between life and death, yet where people have not only survived, but built empires, created art, and thrived for millennia? If that question intrigues you, if you're ready to discover how the Sahara transformed from a green paradise into the world's most iconic desert, then you're in exactly the right place. Hit that subscribe button right now, because this journey is going to change how you see our planet forever. Let's begin. The Sahara Desert stretches across 11 countries: Algeria, Chad, Egypt, Libya, Mali, Mauritania, Morocco, Niger, Western Sahara, Sudan, and Tunisia. This isn't merely a geographic detail, it's a reality that shapes the lives of millions and defines the economic and political landscape of an entire continent. To truly grasp the Sahara's significance, you must understand that it's not one desert but many, each with its own character, its own story, its own relationship with the people who call it home. Geographically, the Sahara sits between two distinct zones: the Mediterranean climate of North Africa's coastal regions and the tropical savannas of the Sahel to the south. This positioning makes it a boundary, a transition zone, and throughout history, a barrier that demanded respect and preparation to cross. The desert's northern edge brushes against the Atlas Mountains in Morocco and Algeria, where snowmelt creates the only reliable water sources for hundreds of miles. To the east, it meets the Red Sea and the Nile Valley, that singular exception to the rule of aridity that we'll explore in depth later. The cultures that inhabit this vast territory are as diverse as the landscape itself. The Tuareg, often called the Blue People because of the indigo dye from their traditional clothing that stains their skin, have navigated these wastes for centuries as nomadic traders. The Berbers, whose settlements dot the desert's fringes, have cultivated an architectural tradition perfectly adapted to extreme heat and precious water. Arab populations control many of the trade centers and historic caravan cities, while the Taubu people of the Taibesti Mountains in Chad have mastered survival in one of the Sahara's most inhospitable regions. Each culture developed unique survival strategies, social structures, and spiritual practices tied directly to desert life. The Tuareg, for instance, organized their society around water access and developed an intimate knowledge of desert navigation by stars, wind patterns, and barely perceptible landscape features. They could read sand like we read street signs, finding their way across trackless wastes with a precision that astonished European explorers. Here's where the story becomes truly fascinating. The Sahara, as we know it, is relatively young. Just 5,000 to 10,000 years ago, much of what is now burning sand and stone was savanna grassland dotted with lakes and rivers. Hippos wallowed in waters where today only scorpions survive. Elephants, giraffes, and crocodiles roamed landscapes now utterly hostile to such life. This wasn't a minor climate variation. It was a fundamental transformation driven by changes in Earth's orbital cycles. The Sahara's greening and desiccation follow what scientists call the African Humid Period, linked to precession, the wobble in Earth's axis over a roughly 20,000-year cycle. When the northern hemisphere tilted more toward the sun during summer, African monsoons strengthened dramatically, bringing rain deep into what is now desert. Rivers flowed year-round, lakes filled and supported thriving ecosystems. Archaeological evidence shows human populations flourished, hunting game and creating the remarkable rock art that still survives in places like Tassili Enaja. In these sandstone formations of southeastern Algeria, you can stand before images painted and carved thousands of years ago, depicting cattle, hunters, and fertility goddesses, proof positive that this was once a land of abundance. The art shows a progression. Early images show wild animals and hunting scenes. Middle period works depict domesticated cattle and pastoral life. And the latest images show horses and camels, documenting in real time the climate's deterioration and humanity's adaptation to increasing aridity. The transition wasn't instant, but in geological terms, it was remarkably swift. Over perhaps 1,000 years, the monsoons weakened and shifted southward. Lakes evaporated, rivers dried to seasonal trickles, then to nothing. Vegetation died back, and without plant roots to hold soil and retain moisture, the process accelerated. People and animals migrated toward shrinking water sources, concentrating along the Nile Valley and the desert's margins. Those who remained adapted, transforming from settled farmers to nomadic pastoralists, learning to move with the seasons and the rare rains. Today, that pattern continues on a vast timescale. The Sahara expands and contracts with these orbital cycles. What appears eternal is temporary. The desert you see today will, in thousands of years, green again, a humbling reminder that human timescales and planetary timescales operate on entirely different wavelengths. Despite popular imagination, sand dunes, those iconic golden waves, cover less than 30% of the Sahara. The rest is rock. Vast stone plateaus called hamadas stretch for hundreds of miles, their surfaces baked hard by sun and scoured by wind-driven sand into surreal smoothness. Gravel plains called regs extend across Libya and Algeria, their surfaces covered with dark, polished stones that create natural desert pavement. Where sand does accumulate, it forms ergs, sand seas that can span thousands of square miles. The Grand Erg Oriental in Algeria and the Erg Chech in Mali contain dunes reaching heights of 600 feet or more. These aren't static features. Wind moves them constantly, grain by grain, creating that characteristic rippled surface and reshaping dune fields over years and decades. The sand itself often glows with an orange-red hue, colored by iron oxide coating each grain rust, essentially born from the weathering of iron-rich rocks over millions of years. But the Sahara's geological showpieces go far beyond sand and stone. The Richat structure in Mauritania, nicknamed the Eye of the Sahara, presents a mystery solved only recently. This massive circular formation, 30 miles across and visible from space, was long thought to be an asteroid impact crater. Geologists now understand it as a deeply eroded dome, where softer rock layers wore away faster than harder ones, creating concentric rings that perfectly illustrate Earth's layered geology. Standing at its center, you're looking at rocks that date back 600 million years, exposed by wind and time. Volcanic landscapes add another dimension. The Tuareg Mountains in Chad and the Hoggar Mountains in Algeria rise from the desert floor, remnants of ancient volcanic activity. Dark basalt flows spread across the landscape, creating stone fields that absorb heat during the day and radiate it at night, further intensifying temperature extremes. Water defines everything in the Sahara. Where it exists, life explodes. Where it's absent, stone and sand reign. Understanding the desert means understanding its relationship with water in all its forms: surface rivers, hidden springs, ancient aquifers, and the engineering brilliance humans developed to capture every drop. The Nile River represents the most spectacular exception to Saharan aridity. Flowing 4,135 miles from Central Africa to the Mediterranean, it crosses the Eastern Sahara without contributing a single drop. Evaporation and irrigation consume far more than tributaries add. Yet this ribbon of water enabled one of history's greatest civilizations. Ancient Egypt emerged entirely because the Nile's annual flood deposited nutrient-rich silt across its floodplain, creating a narrow but incredibly fertile valley through absolute desert. The Egyptian civilization oriented itself along this north-south axis with almost perfect geographic logic. The living cities, temples, and farmland occupied the river's east bank, where the sun rose. The dead tombs, pyramids, and mortuary temples occupied the western desert, where the sun set and descended into the underworld. This wasn't arbitrary symbolism. It was geography made sacred, landscape transformed into cosmology. Further west, rivers like the Ziz in Morocco tell a different story. Fed by snowmelt from the Atlas Mountains, these rivers create narrow corridors of intense green slicing through brown desolation. The Ziz Valley supports dense palm groves, terraced agriculture, and settlements that have endured for centuries. Farmers developed sophisticated irrigation systems called ketaras, underground channels that tap aquifers and transport water with minimal evaporation loss. These systems, similar to Persian qanats, represent engineering achievements every bit as impressive as Roman aqueducts. Oases like Siwa in Egypt and Turgid in Mauritania survive on groundwater, not surface flow. The Nubian sandstone aquifer system beneath the Eastern Sahara contains water that fell as rain during those humid periods thousands of years ago, fossil water, irreplaceable on human timescales. When fractures in rock allow this ancient water to reach the surface, oases emerge like biological miracles. Date palms tower overhead, providing shade for figs, pomegranates, and vegetables growing in carefully tended gardens. Birds nest in the palm fronds. Frogs sing in small pools. Life concentrates so intensely, it seems almost overwhelming after miles of emptiness. But these oases are fragile. Overpumping for modern agriculture has lowered water tables across the Sahara. Springs that flowed for millennia have begun to fail. The delicate balance that sustained these green islands for thousands of years is breaking under contemporary pressure. Desert architecture reflects pure necessity transformed into beauty. With virtually no timber available and limited stone suitable for construction, builders turn to the material beneath their feet, earth. Rammed earth construction and sun-dried mud bricks create structures perfectly adapted to extreme temperature swings. Thick walls absorb heat during the day, preventing interiors from becoming ovens, then radiate that stored heat at night when temperatures plummet. Ait Ben Haddou in Morocco stands as perhaps the most visually stunning example of this tradition. This fortified village, built along a former caravan route, rises from a hillside in a cascade of geometric forms, towers, crenellated walls, and tightly packed houses, all constructed from the same red-brown earth. The entire settlement appears to grow organically from the landscape, as if the hill itself had been sculpted into habitability. These kasbahs, fortified structures serving as homes, granaries, and defensive positions, employed architectural intelligence rarely recognized by outsiders. Small, high windows minimize heat gain while providing ventilation. Courtyards create microclimates, trapping cooler air. Rooms stack vertically, with storage at ground level, living spaces above, and sleeping quarters highest, where rising heat is offset by better air circulation. Every detail serves survival. Cliff dwellings represent another adaptation strategy. In places like the Bandiagara escarpment in Mali, communities carved homes directly into rock faces, creating naturally insulated spaces protected from both sun and raiders. Communal granaries perched on ledges accessible only by rope and ladder kept precious grain reserves safe from theft and vermin. The city of Gardia in Algeria's Mzab Valley showcases yet another approach. Built by Mozabite Berbers in the 11th century, it organized itself around water management and social cohesion. The city rises in concentric circles up a hill, with the mosque at the summit and houses arrayed below in a pattern that ensures equal access to resources. An underground system of channels and cisterns captures and distributes every drop of occasional rainfall. For centuries, the Sahara's economy centered on trans-Saharan trade. Caravans of hundreds or even thousands of camels crossed the desert, linking sub-Saharan Africa with Mediterranean markets. They carried gold, ivory, and enslaved people northward, salt, manufactured goods, and horses southward. The profits were immense, and the risks nearly as great. Salt, abundant in northern deposits but scarce in the south, held particular value. In places like Taoudani in Mali, salt has been mined for centuries from ancient lake beds. Massive salt slabs, weighing 90 pounds each, are cut, loaded onto camels, and transporting across hundreds of miles of desert. In markets of Timbuktu and other cities, salt traded pound for pound with gold, a reminder that value depends entirely on scarcity and need. Cities like Chingti and Wadin in Mauritania owed their existence to these trade routes. Chingti, once a major Islamic center, boasted libraries filled with ancient manuscripts and hosted thousands of pilgrims traveling to Mecca. Its stone buildings and narrow streets still stand, but the city now holds only a fraction of its former population. When colonial powers disrupted traditional trade routes and modern shipping made trans-Saharan caravans obsolete, these cities declined precipitously. Today, the economics have shifted dramatically. The Sahara contains vast reserves of oil, natural gas, and minerals. Libya, Algeria, and other Saharan nations derive enormous wealth from petroleum extraction. Mauritania exports iron ore on one of the world's longest trains, a 1.5-mile-long behemoth carrying 15,000 tons of ore across the desert from Zaouirat to the coast. The train also carries passengers who ride atop the ore cars in conditions that range from uncomfortable to dangerous, but for a fraction of the cost of other transport. Most significantly, the Sahara has emerged as a potential renewable energy powerhouse. Solar facilities like Morocco's Noor complex near Ouarzazate harness the desert's greatest resource, relentless sunlight. The complex generates power for over 1 million people and represents a new vision of the Sahara, not as wasteland, but as strategic asset. Engineers envision far larger projects that could theoretically power all of Europe through undersea cables, transforming the desert from barrier to bridge. Urban centers in and around the Sahara reveal humanity's persistent drive to claim permanence in impermanent places. Some cities thrived for centuries, then vanished. Others endure against all logic. Some were imposed by imperial power, others grew organically from necessity. Timgad in Algeria exemplifies Roman ambition's collision with desert reality. Founded in 100 CE as a military colony, it was built to the standard Roman grid plan with forum, temples, theater, and baths, civilization stamped onto the landscape through sheer force. The Romans diverted water from nearby sources, built elaborate fountains, and created an oasis of classical culture. When Roman power receded, so did the water. Sand gradually buried the city, preserving it nearly intact until French archaeologists excavated it in the 19th century. Today, you can walk its streets, sit in its theater, and marvel at the audacity of building something so fundamentally Mediterranean in such un-Mediterranean conditions. Nouakchott, Mauritania's capital, tells a completely different story. Before 1960, it barely existed, a tiny settlement near the coast. When Mauritania gained independence, the new nation needed a capital. Nouakchott was chosen and transformed almost overnight from desert outpost to administrative center. Built for 15,000 people, it now holds over 1 million, swollen by rural migration, driven by drought and economic pressure. The city expands chaotically, struggling to provide basic services, wrestling with sand encroachment, and exemplifying the collision between traditional Saharan life and modern nationhood. Sacred sites demonstrate yet another relationship with the landscape. The rock-hewn church of Abuna Yamata Ga in Ethiopia's Tigray region sits atop a sheer cliff, accessible only by a terrifying climb-up rock faces with minimal handholds. Why build a church in such an impossible location? Protection, partly, invading forces never reached it, but also faith. The difficulty of access becomes an act of devotion, a pilgrimage that tests commitment. Inside, ancient frescoes cover walls and ceilings, preserved by altitude and aridity, illustrating biblical scenes in colors that remain vivid after centuries. The necropolis of the Valley of the Kings in Egypt represents perhaps the ultimate expression of desert geography, serving death and eternity. Pharaohs chose this remote valley on the Nile's west bank for their tombs precisely because of its isolation and aridity. Limestone cliffs could be excavated deeply, creating hidden chambers for burial. The desert's dryness preserved mummies and artifacts. The location's remoteness was meant to deter tomb robbers, though ultimately nearly every tomb was looted, sometimes within years of sealing. Some Saharan phenomena seem to defy explanation until you understand the chemistry and geology involved. In Egypt's White Desert, limestone formations weathered into surreal shapes rise from the sand, mushrooms, chickens, ice cream cones, all gleaming white against blue sky. These aren't artificial sculptures, but natural formations created by differential erosion. Wind-blown sand scours softer layers faster than harder ones, carving rock into impossible-seeming forms. The phenomenon known as desert roses or sand roses produces crystal formations that look like flower petals made of stone. These form when mineral-rich groundwater evaporates in sandy soil, leaving behind gypsum or barite crystals that incorporate sand grains as they grow. The result looks organic, crafted, almost impossible, but it's pure chemistry. In the Sahara's western regions, you'll find spherical concretions nicknamed melon stones, rocky spheres, some as large as baseballs, scattered across the surface. These formed when mineral-rich water percolated through sedimentary rock, depositing iron and calcium carbonate in spherical patterns around a nucleus grain. Over millions of years, erosion exposed them, leaving fields of mysterious spheres that fueled local legends before geologists explained their mundane but fascinating origin. Salt flats or chots, particularly in Tunisia and Algeria, create some of the Sahara's most otherworldly landscapes. These are ancient lake beds where water occasionally collects after rare rains, then evaporates, leaving behind salt crusts that can extend for miles. Walking across them in certain light conditions creates disorienting effects. The ground seems to glow white, the horizon disappears, and distance becomes impossible to judge. In some areas, the salt crust is thick enough to drive on. In others, it conceals dangerous mud beneath. Where the Sahara meets the sea, strange contradictions emerge. The Red Sea coast presents one of the world's most peculiar interfaces. Turquoise waters teeming with coral and fish lap against shores where it may not rain for years. Resort cities like Sharm el-Sheikh and Hurghada survive entirely on imported water and the income from tourists drawn by exceptional diving conditions. The desert descends directly into the sea, creating a landscape that seems almost surreal. You can swim among tropical fish in the morning and stand in absolute desert by afternoon. The Suez Canal represents perhaps the most economically significant human intervention in the Sahara's geography. Completed in 1869, it transformed global trade by connecting the Mediterranean and Red Seas, eliminating the need for the long voyage around Africa. The canal cuts through deserts so flat and low-lying that sea level is nearly identical on both ends, a geographic accident that made construction far simpler than it might have been. About 12% of global trade now passes through this desert-carved waterway, making it one of the world's most strategic choke points. The Sahara is not static. Its southern boundary, the Sahel, experiences constant tension between desert and savanna. During the 20th century, the Sahara expanded southward significantly, driven partly by natural climate variation, but accelerated by human activity, overgrazing, deforestation, and farming practices that stripped vegetation and loosened soil. The 1970s and 1980s saw devastating droughts in the Sahel that killed hundreds of thousands and displaced millions. Lake Chad, once one of Africa's largest lakes, has shrunk by 90% since the 1960s due to both drought and irrigation demands. Entire fishing villages now sit miles from water, their boats stranded on dry lake bed. Yet this expansion isn't permanent. Studies show the desert's margins fluctuate seasonally by hundreds of miles, advancing in dry seasons and retreating when rains come. Over longer timescales, centuries and millennia, the entire character of the Sahara transforms according to those orbital cycles governing African monsoon strength. We live in an interglacial period when the Sahara is near its maximum extent. In future millennia, it will green again, just as it has repeatedly throughout Earth's history. This knowledge carries profound implications. The landscapes we consider eternal, the endless dunes, the parched valleys, the salt flats, are temporary features on a planet that operates according to rhythms far longer than human civilizations. What we must preserve isn't the Sahara's current state, but the processes that allow it to transform, adapt, and regenerate. The Sahara could be dismissed as wasteland, yet it contains wonders that humble the human imagination. Dunes that flow like frozen waves, stars so numerous they overwhelm vision, silence so complete it becomes almost tangible, rock formations that sculpt themselves over millions of years. If we can find beauty and meaning in the world's harshest desert, surely we can find it anywhere if we choose to look. Now let me ask you, if you could witness only one moment in the Sahara's transformation from green paradise to desert, which would you choose? The last lake drying up, the first caravan crossing, the moment someone discovered water beneath the sand? Share your thoughts in the comments. I read every single one and love hearing your perspectives. If this journey moved you, educated you, or sparked your curiosity, hit that subscribe button and the notification bell. We travel to extraordinary places every week, uncovering the stories that make our planet not just beautiful, but meaningful.